Welcome back to Rust Run. We're continuing our journey in building the guessing game. Let's dive right in. In this video, we're jumping right into the heart of the game. We're going to cover points 4 to 6, converting the user's input, comparing it with the secret number, and giving instant feedback. This is where the game starts to feel real, interactive, and fun. Ready to make the magic happen? Let's dive in and power up our game. The match pattern in Rust is a powerful control flow construct that allows you to compare a value against multiple patterns and execute different code based on which pattern matches. It's similar to a switch statement in other languages, but much more flexible and powerful. Let's see how it works. On line 5, we created variable number and assigned value 3 to it. On line 7, we use a match statement to evaluate the variable number against different patterns in order. First, it checks if number is 1. Since it doesn't match, the program moves to the next pattern. Then it checks if number is 2, but that also doesn't match, so it continues searching. Finally, when it checks if number is 3, it finds a match. As a result, the corresponding block of code executes and println prints "you picked 3" to the console. Once a match is found, Rust stops checking further patterns. If none of the listed patterns match, the underscore serves as a catch-all, ensuring that every possible value is handled. We'll use a slightly more advanced version of the match pattern in our guessing game to make it more dynamic and interactive. Let's talk about the ordering enum. We'll find it very handy when comparing the number provided by the user with the random number generated by our program. The ordering enum is part of Rust's standard library and helps us represent the result of comparing two values. When we compare two values using Rust's built-in CMT method, it returns one of three variants from the ordering enum. Ordering less, the first value is smaller than the second. Ordering greater, the first value is larger than the second. Ordering equal, both values are equal. In this example, we have two variables, a with a value of 10 and b with a value of 20. When we call the CMP method on a and pass a reference to b as a parameter, Rust compares these two values. Since 10 is smaller than 20, the CMP method returns ordering less. And we store this result in the result variable. You're encountering a lot of new concepts that might feel unfamiliar right now, and that's completely okay. At this stage, just focus on following along and repeating the steps with me. We'll dive deep into each concept in the upcoming videos, so don't worry, you'll understand everything in time. We're back to coding. Now that we know how to compare two numbers, let's put that knowledge to the test. This time, we'll compare the number provided by the user with the random number generated by our program. So we execute the CMP method on the guess variable and pass a reference to secret number as a parameter. We're getting a type mismatch error because guess is a string, while secret underscore number is an integer. To compare them, we need to convert guess into an integer. We'll dive deeper into variables and types in the next video. Let's fix it. I'll redeclare guess as a U32, an unsigned 32-bit integer. This technique, called shadowing, allows us to reuse the same variable name while transforming its value and even changing its type. Now, let's call the trim method on guess to remove any unnecessary white spaces. After that, we'll use parse to convert the string into an integer. And finally, we need to handle potential errors using the expect method, just like we did earlier when handling user input. So now, if the program fails to parse the user input into an integer, it will panic and display the message. Please type a number. Great, we have fixed our type mismatch error. Now we just have a warning because result of the comparison isn't used. We can easily fix this by storing it in a variable. So the result of the comparison is an ordering enum. But instead of just storing it in a variable, we'll use it smartly to notify the user whether their guess is correct, too small, or too big. Let's bring the ordering enum from the standard library into scope so we can use its variants directly. Okay, now we can use a match expression to execute different code depending on the result of the comparison. This will allow us to respond dynamically based on whether the guess is too small, too big, or correct. So we take the result of the comparison and apply a match pattern to it. Since we already know all possible outcomes, less than, greater than, or equal, we can display the appropriate message to the user based on their guess. So let's define the message we want to print when the guessed number is too small. And now let's add the message for when the guess is too big. And finally, let's set the message to display when the guess is correct. Great. Now we can finally test our program and see it in action. Let's use cargo run to start our application and test if everything works as expected. The secret number generated by our program is 59. Let's try guessing something smaller and see what happens. Too small. That's what she said. Looking good so far. Let's go for another round, but this time we'll guess a number that's bigger than the secret number. Too big! Sounds perfect. The game is doing exactly what we want. And finally, let's correctly guess the secret number and win the game. Awesome results, and I'm so happy to have you with me on this journey. It's been a blast building this together. In this video, we covered points 4 to 6 and built the core logic of our game. In the next video, we'll polish it up by allowing multiple guesses and handling invalid input to make the game more user-friendly. Hey, this course is completely free and created by just one person. If you're enjoying it, don't forget to subscribe and hit the like button.